So hello guys, this is our question. I solved this earlier, but due to some error, my recording is corrupted. So okay, so in this question there is some resistor are given. There is switch S1, some one capacitor, some resistance, and some input. And the question says not find R. Okay, not find R. R is given. This is R. R is given. What is happening here? Okay, R is given. We have to find out this R in when switch S2 is closed. Okay, uh, first see the circuit for yourself, then come back to the solution. And these are the some initial condition. This is 81k kilo ohm. This is Q1. The Q1, Q2 are same, and the voltages are the Vs. This is our prime focus. Vs by V out. V out are given, and switch 1 is open and switch 2 is closed. So a person who knows the Miller's theorem will get the solution instantly, and who do not knows Miller's theorem बने रहो वीडियोस के अंदर पता चल जाएगा. So Miller theorem says whenever there is a impedance connected between input node and the output node, we can decompose this impedance into two parts, Z1 and Z2. Okay, this is some black box which has a gain of AV, and there is an impedance connected between input and output terminal of this black box, and we can decompose this impedance into two parts, Z1 and Z2. Z1 value is Z upon 1 minus AV, and Z2 value is Z upon 1 minus 1 by AV, and Z is the original impedance. Remember one thing about Miller theorem. Miller theorem says Miller theorem increase the number of poles of the system, but it doesn't say anything about zeros of the system. In other words, it usually ignores the zeros of the system, which has some effects on the system. So, but it is a good approximation to find out the poles and the input impedance of the system. Okay, I will take another lecture for the Miller's theorem at some other time. But for timings, you can understand that Miller's theorem says that we can decompose the impedance into two parts, Z1 and Z2, and how? These are the formulas. Now let me read over the circuit. Uh, these gain are the AC gains or small signal gain, we can say. In small signal, we can ignore we can show the constant voltages. So VCC will ground, and the prime focus of our system is Vs by V out, so we can ignore this part as well. But as the AC as the uh, in the AC ground, this capacitor shorts. This capacitor is also short, and this switch is closed as we are finding all the parameters in S1 when switch 1 is closed. So circuit will look like this. This R1 is jumped over this branch, not connected to this point, so don't be confused. So it will connect it to RE, R2, and this R1, and we are applying the Miller's theorem here. Why? This is our prime focus Vs, so Vs is our input, and it is connected to the output, so we can apply Miller's theorem. Miller's theorem says that we can decompose this resistance in two values, two impedances, and the input impedance I am printing as R dash, and the output impedance I am printing is R double dash. And we can also say that this is RE, this is RE, and this is R2, and this terminal is AC ground, so this R1 is also one terminal is connected to the ground, and one terminal is connected to the R2, so R1 is parallel to R2 here, and there is one output impedance which is coming to the decomposition of this original R by the Miller theorem. So this is R dash, and R double dash has the value of R1 minus 1 upon A V, and the question asks us to find out the R input. So at this we have to find the Rin. Rin is the parallel combination of all these R dash parallel. These are input, R I can say R naught. Okay, we'll say this R naught. This R naught. Okay, but this R naught is nothing but the impedance of the BJT. Input impedance of the BJT. The input impedance of the BJT is nothing but the R pi. Okay, R pi, and R pi has the formula of R pi has the formula of beta upon GM, and the question says that R is large, means very large, uh, large. So we can say that R pi is also very large. So this R pi is equals to R naught. So this is very high impedance. So we can ignore this impedance as this is the parallel combination of R dash and R naught. So our R in is simply R dash. Okay. Now we can find out R dash. R dash is the value of R upon 1 minus AV, and R is given as R is 9 kilo ohm and 1 minus AV. When switch 1 is closed, then we have given this 0.99. This is given. If we subtract this, we will get 10 kilo upon 0.01, which is R dash. We will get what we will get 10 raised to power 3 means 1 upon this is 1 upon 100 raised to power 2, 10 9 into 10 raised to power 5 ohms, and we can say R dash is zero point 0.9 mega ohms, or 1 mega ohm, you can say 0.9 mega ohm. So I hope you like this solution.